Hello boys and girls, this is Mr. Kizik, and in this video we're going to look at the homework and then continue with trig functions. And I apologize, I'm not there again today. So your homework was to look at just one problem here, number one, and it was looking at just the ratio itself here. So with this problem, the first thing you had to do was actually find PQ. So you had to utilize the Pythagorean theorem. 50 was a hypotenuse, so 14 squared plus b squared equals 50 squared. You go about and you solve for it and you get 48. And then you just do the ratios for each trig function. So sine of q is opposite 14 over hypotenuse 50. And then you reduce it. Cosine of q would be the adjacent side, which is 48 over 50, or 24 over 25. Then tangent of q would be opposite over adjacent, so 14 over 48 is 7 over 24. And then you just do the same concept for angle r. So take a moment, look at it before we move on in the video. Alright, so what we're going to be doing here is this. We are going to be looking at how we find missing sides with these different trig ratios. So if I look here in number one, for example, what you want to do is relate the sides that are given to the angle that's given. You still have to look at the 90 degrees. You can't just ignore it, but you're going to look at the angle that's given. So what is x in relation to 28? Well, that would be the opposite side. And then what would be the 19? That's the hypotenuse. So then you would go back to your notes and you say, okay, which trig function deals with opposite hypotenuse? And if you remember the mnemonic thing, SOHCAHTOA, you would realize that it's SO or sine. Because what is sine? As we look back here, sine is opposite over hypotenuse. So all I'm going to do is just rewrite this trig function with a ratio. So sine. Now we have to talk about an angle here. So in math, and maybe you know this already, we use a variable called theta to represent angle measures. So sine theta equals opposite over hypotenuse. Now all I'm going to do is just fill in these words and variables with numbers and variables. So I would have sine of the angle, 28, equals, what's opposite? X. What's the hypotenuse? 19. And now this becomes just an algebra problem. To get x by itself, multiply each side by 19. So I'd have x equals 19 times sine of 28. So a couple things to remember here, and that I have students have asked in the past. You cannot multiply the 19 and the 28. Because this right here, sine of 28, that's what goes together here. So that goes together. I can't multiply the 19 with the 28 and then take sine of that number. So technically, what we have here, this is the exact answer. But we want to get the rounded answer here because this means nothing to us. 19 sine 28 means nothing. We actually want to find a measurement. So this is where your calculator comes into play. If you don't have a calculator, I would definitely go and get one. I would also recommend you strongly not to use your calculators on your phones. If you have a Samsung, it's not too bad. It's actually would work decently well. But if you have an iPhone, no, just absolutely not. Don't use that calculator. I'll show you or tell you in a little bit what you would have to do in order to plug them in, and it's just too confusing. So the one thing you want to make sure is that your calculator is in degree mode. So if you are planning to use your Samsung phone, which again, don't suggest it, but if you are, by default it's in degree mode, so you're good with that. If you're using a school calculator, they should all be in degree mode because, well, other classes have done it already, so it should be already in degree mode. You would know that you're in degree mode with the school calculators if you look at the bottom, it has DEG. If you have a graphing calculator, what you want to do is press mode and then the third level down has radians and degrees, and you want to make sure degree is highlighted. Once you have your calculator in the correct mode, all you're literally going to do is just type in the stuff right here. You're going to type in 19 times sine of 28, and it says round it to the nearest tenth, and you're going to get around 8.9. Let's look at another one to see how it works here. So I got the 41 degrees right here. So I would say, what's the relationship with the 32 and 41? And you would say it's adjacent. And then you would say, what's the relationship between the x and the 41? And you would say it's opposite. And then the next thing you would want to do is, okay, I have my two sides, adjacent and opposite. Which trig function deals with just those? And you would say that it is tangent, SOHCAHTOA. So it'll be tangent theta equals, and then the ratio of a tangent is opposite over adjacent. Now I'm going to fill in what I know here. Tangent of the angle 41 equals opposite x over adjacent 32. Again, get x by itself and multiplying each side by 32. So 32 times tangent of 41, that's what x is going to equal. And now we go to our calculator and we're just going to type that in there. And I'll do 32 times tangent of 41. And I would get that to be around 27.8. Alright. Let's skip down to number 5. So number 5, we're going to do the same thing. What's the relationship between the angle and the sides given? So in this case here, x is the hypotenuse, 15 is opposite. So you would say to yourself, what trig function deals with opposite and hypotenuse? Again, that's like number 1, it's sine. Sine theta equals opposite over hypotenuse. You don't need to necessarily write this step down here, but I'm just doing it now so that you get in the habit of remembering what the ratios are, and then eventually when you get better at this, you probably won't have to do it. So then, fill in the blanks here. Sine 33 equals, now opposite's 15, hypotenuse is x. So if you notice with this problem here, what's different about it is that x is now on the bottom. You're still, if you're using algebra here, you're still utilizing the same methods. To get x by itself, you would have to multiply each side by x to get rid of the fraction. So now you have x sine 33 equals 15. And then to get x by itself, you'd have to divide each side by sine of 33. Because remember, sine of the angle measure, they go together. So now in your calculator, all you would just have to do is take 15 divided by sine 33, and I would get roughly 27.5. And that, ladies and gentlemen, is how you would find missing sides of right triangles. Now, I did mention before, like I said, Samsung phones, they're pretty good, they're fine. At least the one I have here acts like a normal scientific calculator. But the iPhone, this is where the iPhone gets a little confusing. What you would have to do in an iPhone is this. Instead of just typing 15 divided by sine 33 like a normal person, you would have to type in 33, then press sine, and then some of the iPhones you have to press equal, or once you press the sign you get the number, but then you're going to get a decimal. And the thing is this, you don't want to round that decimal right away, because then you're going to take 15 divided by that decimal, and you're going to get an even more rounded answer. So what you have to do instead is basically memorize the whole long decimal, and then do 15 divided by that and get your answer. So, that's why I recommend not using any of your phone calculators. Use a scientific calculator. If your calculator does not have sine, cosine, tangent buttons, like dedicated buttons on your calculator, then you also can't use it. Just like everything in geometry is real world based. I can apply it to many different things. So therefore, let's look at a word problem. With any of these word problems, I always recommend to students, draw it out for yourself. Not expecting, Van Gogh type of drawings, but get a visual example for yourself. So you got Jake. He's leaning a 12-foot ladder against his house. So here's his house. Leaning a ladder against it. And it's 12 feet. If the angle formed by the ladder and the ground is 68 degrees. So a lot of these problems, it is really important where you label these angles, because depending on where you label the angles determines what the setup would be for the trig functions. So since it says the angle is formed by the ladder and the ground, that means it has to be down here. And then we want to know how far is the ladder away, the base of the ladder, from the house. Hopefully you see right here, I do have a familiar shape. I have a right triangle. See? Told you guys you can't get away from triangles here. So with that, it becomes like a problem like we did before. Label the sides that you have in relation to the angle. 12 is the hypotenuse. X is the adjacent side. What are we looking for? Well, which trig function deals with adjacent hypotenuse? It would be cosine. So cosine. And this time we're going to just go right into replacing our variables. So cosine of 68 equals x over 12. Means I got to multiply both sides here. So x is going to be roughly, let me get my calculator here. 12 times cosine of 68. It's going to be around 4.5. And because it is a word problem, you label phi. Okay. So that's how you do finding missing sides using trig and a word problem. So we're not done yet here. So on this particular page, on this particular pack, I should say, I would like you to do, the evens, all right? So do the evens on this page here. So 2 through 14, all right? I know we didn't go over example problem like 12 or 13, but I want to see what you could come up with that. Let me just write it here in case you forget here. So evens numbers 2 to 14. Alright. To continue this video here, not going to be any more difficult. Just a different kind of setup. That's why we're continuing this video. Inverse trig ratio is going to be using now. So instead of finding missing sides, we're going to find missing angles. The concept is still the same in terms of relating your angle to the sides that are given. So if I look here in your other packet, here's x right here. Again, no measurement, but I'm still relating to that angle. So what's 24 in relation to the x? The hypotenuse. What's 15? Opposite. So which trig function deals with opposite hypotenuse? Hopefully getting the hang of this, it would be sine. So sine theta equals opposite over hypotenuse. Now we're going to fill in the blanks. Again, nothing new yet. So sine of, now instead of angle, measure, it's just x, equals 15 over 24. Now, I could reduce this fraction. I could reduce 15 on 24, but it's not necessary because if you remember from the previous video, every multiple of that fraction, so if I do reduce this, I get 5/8. Every multiple of 5/8 will be related or goes to just one angle measure. So there's no reason to reduce it because multiples of 5/8, which is 15 over 24, will be the same angle measure. Alright, so now how do we find x here? Many students have the notion that, oh, well, I just divide each side by side to get x by itself. But that's not the case. Think of in Algebra 2, when you were learning logarithms and natural logs, and you had to solve for x that was with the logs and natural logs. You use something called inverse functions, which basically you had to raise things to a certain power on both sides. And that's what's going on here. You technically have to raise each side to the inverse of that trig function. So you're raising both sides to the inverse of sine, which is sine to the minus 1. And this is what essentially what happens in the background. These two cancel out. And I'm left with just x. And then the other side, I have inverse sine of 15 over 24. And that's all you can do there. After that, you have to go to your calculators. So if you notice on your calculators, right above sine, cosine, tangent, there should be sine minus 1, cosine minus 1, tangent minus 1. What you would have to do is press second, and then in this case we want sine, so you press second sine, and sine minus 1 comes up, and then you type in 15 divided by 24, and then whatever you get, that is your angle measure. So this is, and then what is it, nearest 10th? So this is going to be roughly around 38.7 degrees. And that's it. Same basic setup, same logic of what's the relationship between the angle and the sides here. And then all you just have to remember is you're taking the inverse of that trig function. So let's look at another one here. Let's look at 2. So here's x. Let's make this back to normal here. What's the relationship between 8 and the x? Oh, that's the adjacent side. What's 11? Oh, that's the hypotenuse. What trig function deals with adjacent hypotenuse? Cosine. So cosine, what's the angle? X equals adjacent over hypotenuse. Since x is where I'm trying to find the angle, I take the inverse of both sides. So I would have x equals cosine to minus 1 of 8 over 11. And then I would just go to the calculator. I would press second cosine of 8 divided by 11. And I would get this as around 43.3 degrees. And that is it, how you find angles of missing angles for a right triangle. Again, everything we've done so far is just for a right triangle. We'll be talking about in the future what happens if it's not a right triangle. There are extra problems here if you do want to try them. And then the next section is basically mixing it up. So you just have to realize, what am I trying to solve for here? If x is an angle, you're using this method. If x is the side, then you're using the other method. I want to look at number 18. So we got Jaden. Jaden is flying a kite and lets off 275 feet of string. So there's Jaden with the kite. Lets out 275 feet of string. So there you go. So the kite is 150 feet above the ground. So we got this height here. 150 feet. Okay. And we assume the string is straight, there's no curve. What angle does the string make with the ground? So you're assuming here this 275 is going to the ground. Right. So again, hopefully you see, here's the ground, I have a right triangle. And what we're trying to find is, we're trying to find the angle with the ground, so that's right here, x degrees. Label we have, this is the opposite side. That's the hypotenuse. So this is now sine. Sine of x is what I'm trying to find, is 50 over 275. Again, I could reduce the fraction, but no reason to. So x equals inverse sine of 150 over 275. I go to my trusty calculator, and I'm going to press second sine. 150 divided by 275. And I get that this is roughly around, assuming it's the nearest 10th, 33.1 degrees. And that, ladies and gentlemen, is how you deal with problems that are finding missing angles. So now in this packet here, I would like you, might as well just continue the theme here, I would like you to do the evens on this page here. Again, if you have any questions or concerns, please feel free to email me and I'd be glad to help you. This is Mr. Kiesik, signing off.